Okay, and problem number 10, A and parts of B and C. So if it's compounded continuously, we apply this formula right here. So we have 500,000, 3.85, so that's E. The rate is 0.0385, and 30 years times 30, and that needs to be in the exponent. Again, if you're using these calculators, you have to be careful that you might need to put a parentheses around this. Otherwise, you end up doing 500,000 e to this, and then you do times 30 at the end if you use these calculators without putting parentheses around this part. So if you use a scientific, make sure you use parentheses around here, and then it'll work like this, or just use the TI's 84s. So we have 500,000 right there. We have e to the x, 0.0385 times 30, and we will get our answer of, when you look at it carefully, 1.5 million. So that's equal to $1,587,011.71 if you want to get technical. Now, this is for 30 years. So how much will his monthly payments be? So if I take this amount here and I divide it by 30 years and I divide it by the 12 months every year, I'll have my answer for his monthly payments. If you're using these, or even if you're using the scientific calculators, I need this thing divided by 30 times 12. So divided by, now if you do here, this won't keep this in the denominator, so parentheses 30 times 12. I need to punch it in like this. So it's going to take this 1.5 million, which is right there for answer, and divide it by that, and I end up with $4,408.36 if you care about, or 37 cents if you round it off. So we'll call it $4,408 and some change, as again we'll call it 37 cents. So the next one down says shorter terms means slightly higher interest rates. 4.2% for 15 years. So basically what I do is I change this to 0.042 times 15. I'll get a higher number here, or I'll get a lower number here, but I have to pay it off in 15 years. So then I'll take this number here that I get here and divide it by 12 times 15 years, because now you're only making these payments for 15 years. You will see that the monthly payment will go up, but you only a bit, not a whole lot. Not even $1,000, but you only pay it for 15 years. So instead of paying $4,400, you're not even going to be paying $5,400. You'll be paying less than that, but you only pay it for 15 years rather than 30 years. So if we wanted to end up paying exactly $1 million for the house and locked in a 3.5, plug in that $1 million. So I want $1 million equal to, the original price was 500,000. E, we know the interest rate is 0.0385, and then I wanted to find out how long the term would have to be. So if I divide both this into here, that's a double the amount. So I'll have 2 equals E to the 0.0385t. But now because I'm dealing with E, I don't take a log, I'll take a natural log. It's just a slightly different button on the calculator. You have log versus natural log. So now I do the same power properties and I do the same division that I did on earlier videos. I will leave that for you to figure out exactly how long the term should be. It will be, in the end, 18 years.